This lovely planet is Venus with corrosive sulfuric acid clouds, temperatures near 500 degrees Celsius, and pressure strong enough to crush steel. You'd have to be thrown onto it today to realize how brutal life on Venus would be. In the solar system, Venus is the third brightest object in the sky. After the Sun and Moon, its path across the heavens has inspired countless researchers and poets in the past. People once thought it was a fast-moving star until the first telescope revealed it was actually a planet. Venus often accompanies the equally bright Jupiter across the night sky, while Mars, with its reddish hue, is harder to discern as Earth's closest cosmic neighbors. When the Soviet Union successfully landed a probe on an alien world in the 1960s, the target was beautiful Venus. Only then did we realize this planet wasn't so lovely. From the 1970s to the early 1980s, the first probe successfully reached Venus's surface, marking a milestone in space exploration. In 1975, the Venera 9 transmitted the first images of Venus's surface back to Earth. At that moment, human fantasies were shattered by reality. The cameras didn't capture lush jungles but a barren, rocky landscape, a desolate, impoverished plain shrouded under a dim, yellowish sky. A thick atmosphere swallowed everything. The images showed angular rocks scattered across the surface. If a tropical paradise ever existed, it had long been destroyed. What remained was clearly a desert of sharp or rounded rocks, uniformly dull in color, the ground dry and dusty, almost like baked clay. No movement, no color variation, no signs of life, only a planet's silent existence. Extreme heat and pressure make life impossible. In 1982, the Venera 13 sent back Venus's most famous images, color panoramas vividly showing the surface's monotonous brownish-gray tones and hazy atmosphere, the probe's own shadow, like a duty cast on a surface both familiar and utterly alien. These images were a scientific triumph, yet an emotional disappointment. All probes landing at different sites revealed the same desolate scene. When NASA launched the Magellan probe to Venus in 1989, it was clear optical cameras were useless here. Venus's atmosphere is too thick and opaque. Even the most powerful telescopes could only see a milky yellowish barrier, but Magellan took a different approach. Its radar eyes pierced the dense clouds, bringing a new image of Venus. It didn't send back traditional photos but radar echoes converted into topographic maps. Venus's surface was almost fully mapped for the first time, presented in vivid color images. Varying color shades highlighted terrain, elevation, material composition, and geological structures became clearly visible, revealing a world of intense geological activity. Massive volcanoes, fissures stretching kilometers, plains covered in lava flows. Particularly striking was the discovery of Maxwell Montes, Venus's highest mountain range, towering over 11 kilometers above Everest. Mont Mons and Sif Mons volcanoes also showed signs of recent eruptions. Magellan's images were dreamlike, revealing a world boiling and churning beneath the clouds. Magellan was a breakthrough, though its images didn't show Venus's true appearance. They revealed its true structure. The Venus Express mission unveiled another side of Venus. Europe's first space probe, designed specifically for Venus exploration, launched on November 9, 2005. From Kazakhstan's Baikonur Cosmodrome, entered Venus's orbit on April 11, 2006. The mission lasted until December 2014, providing 8 years of invaluable data to the scientific community. The mission focused on Venus's atmosphere, climate, and geological activity. The probe, weighing 1,270 kilograms, carried 7 scientific instruments designed to study Venus's dense and complex atmosphere in detail. It revealed the structure of the cloud layers for the first time, allowing us to understand the chemical composition of atmospheric gases and their interaction with the solar wind with considerable precision. Venus Express detected a thin ozone layer in the upper atmosphere, captured spectacular images of a double vortex over the South Pole and found evidence of an ancient ocean. This rekindled fantasies that Venus might once have been a tropical green world indeed. Numerous simulations based on Venus Express data suggest this is highly likely true billions of years ago before the greenhouse effect turned its surface into a furnace. Our beautiful neighbor may have been a green, possibly habitable world. The probe also mapped a complete temperature profile of the southern hemisphere, showing that despite the extreme environment, Venus still has dynamic processes, possibly remnants of its lush past, but on its way to the Sun. Humanity's first solar probe, Parker, cleverly used Venus as a cosmic slingshot, harnessing its gravity to accelerate during multiple flybys between 2020 and 2022. It aimed its wide-angle imager at Venus's surface, causing a small sensation since the Venera probes. These were the first true images of Venus's surface in visible light from orbit. The images showed a world glowing faintly, Aphrodite, Terra, and Tellus Regio planes appearing as faint silhouettes despite the thick clouds. The faint glow from the hot surface penetrated the dense atmosphere, making these images possible. The images weren't as clear as those of Mars or the Moon, but a ghostly glow of Venus against a starry backdrop. Particularly striking was the glowing oxygen halo in Venus's upper atmosphere, appearing as a delicate arc of light in the images. These images were not only technically stunning but emotionally evocative. Whether a burning hell or a frozen wasteland, Venus still holds the power to stir the human heart. In 2023, scientists announced the discovery of potential biomarkers in Venus's atmosphere. This news sent shockwaves worldwide. To investigate these traces of life beyond Earth, NASA planned two ambitious Venus missions, Da Vinci and Veritas, scheduled for launch between 2029 and 2031, aimed at studying Venus's atmosphere and surface with unprecedented precision, searching for microscopic traces of life. Both missions are part of NASA's Discovery program, designed to promote cost-effective, high-value scientific space projects. The program aims to answer unresolved mysteries of the inner solar system through more low-cost probes, at least giving us a fuller understanding of our cosmic neighborhood. Da Vinci consists of an orbiter and a spherical descent probe. The latter will penetrate the dense atmosphere to the surface, the first true Venus landing since the Venera probes. During descent, Da Vinci will analyze the chemical composition of atmospheric gases, particularly noble gases and trace elements, to reveal Venus's formation history. It will also capture high-resolution images of geological structures, focusing on terrain known as tesserae to search for clues of tectonic activity. Veritas, an orbiter, will use cutting-edge radar technology to map Venus, named the Venus Emissivity, Geodesy, and synthetic aperture radar topography and spectroscopy probe. It will create a 3D map of Venus's surface, measure rock emissivity, and search for active volcanoes and tectonic movements. Its goal is to clarify the extent of Venus's current geological activity and whether processes like plate tectonics or subduction are still occurring. Researchers also hope to verify if simulations of a tropical green world are true. Those early science fiction writers may not have been entirely imagining. Then there's Envision, the European Space Agency's second Venus probe, set to begin comprehensive studies of Venus in 2031. Its goal is to systematically study the planet from its core to its upper atmosphere, deeply understanding the interplay between geological processes and climate. Envision is part of ESA's Cosmic Vision program and collaborates closely with NASA, which will provide critical equipment like the synthetic aperture radar system. The mission aims to answer a core question: why, despite Venus and Earth being so similar in size and position, did their evolutionary paths diverge so drastically? To this end, Envision will explore Venus's surface and internal geological evolution, assess its current geological activity, and search for evidence of ancient oceans. If oceans once existed, their traces may be preserved in the oldest rocks by the mission's end. We'll better understand when the extreme greenhouse effect began and why Venus ultimately became a scorching inferno. Technically speaking, Envision is equipped with today's most advanced instruments. The probe will carry multiple radar instruments to map surface and shallow subsurface structures. 3 spectrometers will analyze the chemical composition of the atmosphere and rocks. A subsurface radar will probe up to 1 kilometer beneath the surface. Additionally, a radio tracking system will measure Venus's gravitational field to infer its internal structure.